We are ready to talk about directions for review and preview 5.1.4. For question 34, we have a generic rectangle, and you have to start by filling in the missing areas and the missing dimension. So thinking about what times what will give me 12. What is 2/3 times 1/5? So work your way through finding those missing pieces. Then don't forget to say this multiplication problem being represented as this times this, and this is what we get. So I'm looking for blank times blank equals blank. And you can tell right away, they already give us this first one, 4 1/5. So 4 1/5 times something equals, and then give me the grand total. For question 35, it starts off by saying draw a rectangle. There are no specifications on the size, but if you're going to plan ahead and think through this, it's going to ask you to enlarge this rectangle, so don't make it too terribly big to start with. So in the space over here, I'm looking to see your rectangle, and I need to see that it's labeled original. I'm also looking to see what are the side lengths that you have to start with. The question asks you to enlarge it so that the ratio of the sides of your new rectangle to the original is 5 to 2. So if it's new to original, and it's 5 to 2, it might be helpful to think of what would 5/2 equal as a mixed number. That tells you how many times as big as the original, the new one's going to be. Another option you have would be to take whatever your side lengths are on your original times 5/2, and if it doesn't come out evenly, you'd have to make it a mixed number. So show me your original, label it original, and then label the side lengths. Work through the steps to enlarge it by this ratio. Show me that this is my enlargement, and show me those side lengths. Those are the things I'm looking to see there on 35. For question 36, they give us a whole big long list of fractions, and we see a number line that's already on your answer sheet for you here in part A. And if you look closely at that number line, you're going to barely be able to see some dots along there. And they're asking us to label these dots using the list of fractions that we have. You're going to see some that are close together, especially right there near 0. So you have to obviously think about which ones are very small. Which one would be the smallest of those? You kind of have to put those in order. Once you have all of these points labeled all the way across, and keep in mind, if it gets too crowded and you need to write up above and drop an arrow to the specific point, that's fine. But I am going to look to make sure they are all correct in the right order. So just watch out for that. Once you have all those labeled, part B asks, which of these fractions are greater than or equal to 1? So for part B, you're going to have 4 answers to give. Part C, which of these fractions are close to the number 1? That means they could be a little bit less, they could be exactly 1, or they could be a little bit more than 1. Part C will actually have 5 answers. Part D will have 2 answers. And for part E, there will be 4 answers. Any order on those is fine, but I will be looking to make sure all of them are there. For question 37, Richard is describing his strategy for, looks like converting some decimals to percents or percents to decimals. And he shows some examples of what he's done and how he's thinking about this. Your job is to look at all of those examples that are shown and decide if you agree with his idea or do you disagree with his idea, and tell me why. For question 38, we have in A, B, and C 3 division problems that can be mental math. We're dividing by 10, by 100, and 1,000, so there's very little work involved. Then for part D, it's asking you to describe in words what's going on with this decimal point. So in part D, I'm looking to see where you're describing which direction the decimal is moving, how far the decimal is moving, and why is it that you're moving it in that direction and that distance. So using words to tell me about that for part D.